This video is about acceleration, instantaneous acceleration, and average acceleration, and its relationship with the velocity versus time graph. Most objects don't travel at constant velocity. Quite often, an object's velocity is changing. And when an object changes its velocity, we say that it is accelerating. Acceleration is defined scientifically as the rate of change of the velocity. That is the change in velocity over the time interval. In everyday language, the word acceleration means to speed up or increase speed. However, this is imprecise and it's not really in agreement with our actual scientific definition of the word acceleration. Scientifically speaking, acceleration is really the change in velocity. And remember that velocity is a vector, right? So the object could be speeding up, that's accelerating. It could be slowing down, that's accelerating as well. Or even it could be changing in direction. All three of these things mean acceleration. Well, you already know that increasing speed means accelerating, but you maybe didn't hear about that decreasing speed is accelerating. In fact, you probably heard decreasing speed in common everyday language is called decelerating. You see, if you had a car that was speeding up, it would be moving, say, to the right in the positive direction, and the acceleration would be also in the same direction. But if the car was slowing down, then the acceleration would be in the opposite direction as the velocity. So if we were considering this car moving in the positive x direction to the right, the acceleration would be negative. So I'd rather think of slowing down, or the word decelerating, to be thought of as acceleration in the opposite direction that the object's moving. And speeding up is when the acceleration vector is in the same direction as the velocity. So the term deceleration can be ambiguous, and I'd rather not use it in class. And you might think, well, maybe just deceleration is always negative acceleration. But that's not always true. What happens if the car was moving to the left with the acceleration going to the right? And now the acceleration is positive. So then deceleration can either be positive or negative, and this is all getting really confusing. So let's just agree not to use the word deceleration in physics class. Okay, so we know that if you increase your speed or decrease your speed, you're changing your velocity. But maybe you didn't know that if you were to go around a turn on a highway with a car at the same speed, you're actually accelerating. The reason you're accelerating while you're going around a corner at constant speed is because your direction is continuously changing. The velocity at different points in this circle is going to be tangent to the circle, and so the velocity is always changing direction. And remember that velocity is a vector. So if you change your direction, you're also changing your velocity. So in general, acceleration is the change in velocity over time. The symbol we use to represent the acceleration is a small letter A. I'm going to put a little vector sign above this because this is a vector. And it's the change of velocity, which is typically measured in meters per second, over the time interval, which is typically measured in seconds. So the units of acceleration are meters per second for every second. And that might be helpful to think of that. It's how many, I just gained 10 meters per second in that 1 second time interval. That's really what it is. Now, it's commonly written instead as meters per second squared. So before we were talking about average velocity, instantaneous velocity in the previous videos, and we learned how these definitions could be used and applied to position time graphs, x versus t graphs. Let's now take a look at velocity time graphs. So here we have a velocity plotted on the y-axis in meters per second versus time plotted on the x-axis in seconds. And let's say we have an object that is continuously increasing in speed. Maybe at time 1 second it's going about 10 meters per second, at 2 seconds it's going now 20 meters per second, and at say 3 seconds it's now going 30 meters per second. This is an increasing speed situation. Now, if I were to ask you to take the slope of this graph, what do you think that represents? So the slope is equal to rise divided by run. What is the rise? That's change in velocity. What is the run? That is the change in time. So if the slope is the change in velocity divided by the change in time, what does it represent? It's the acceleration. So we learned earlier that the slope of a position versus time graph was velocity. Now we're learning that the slope of a velocity versus time graph is acceleration. This is a big key idea, and you should remember this one. As we had done with average velocity and instantaneous velocity, we had gained some insight by plotting a position versus time graph. Now we're going to take a look at the differences between instantaneous acceleration and just average acceleration and how they pertain to a velocity versus time graph. The average acceleration is simply just the acceleration over a certain time interval, delta t, for example. Whereas the instantaneous acceleration is the acceleration at a particular instant in time. And we're really taking the same definition of acceleration equals the change in velocity over the change in time, but we're looking at a very, 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 very short time interval, delta t. Take a look at the next page in your notes. To distinguish between average acceleration and instantaneous acceleration, if you take the slope of a line between 2 points on the curve of the velocity versus time graph, so this particular line right here, it's basically a chord, you're getting the average acceleration. So it's the acceleration between 2 points on the graph. However, if we take the slope of a tangent line to 1 point, like A, then we're finding the instantaneous acceleration. Okay, to wrap it up here, acceleration is defined as the change in velocity over the change in time, which means you could speed up, slow down, or change in direction, and in any of those cases would be accelerating. And when you have a velocity versus time graph, the slope of that graph represents acceleration. If you take the slope between 2 points on the curve, then you've got the average acceleration. And if you take the slope of the tangent line to 1 point on the curve, then you've got instantaneous acceleration. Okay, that's it for this video.